Alright, this is problem 18 from the review sheet. This problem is, while standing on a bridge, a student throws a rock up into the air. It takes the rock 3.8 seconds to hit the water 32 meters below. With what initial velocity did the student throw the rock? So first I've got my picture of my student on a bridge. The rock goes up, 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 comes down, 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 all the way into the water below, 32 meters lower than the student. My motion map has my velocity upward, but getting smaller because my acceleration is down. I took the time to write out my 5 letters to start the problem, something that you should always do. And in this particular problem, we've got something that goes up and comes down, but goes lower than its initial position. First thing we can always write is that the acceleration is negative 9.8 meters per second squared. The rock lands in the water with a time of 3.8 seconds after it was initially thrown, and the initial velocity is what the question's asking for. Now we know that it starts out in the person's hand and lands in the water 32 meters below. The D here is not asking for the total distance that the rock covers, it asks for how far it is from where it starts to where it ends up. And that is 32 meters below the student, so that's a negative 32. From here, we're going to use the equation that does not have VF in it because it's our blank spot. So D equals V naught T plus 1/2 AT squared. We're trying to rearrange this for V naught, so I'm going to subtract away my 1/2 AT squared term. So it becomes D minus 1/2 AT squared equals V naught T. From here, I'm going to divide out this T, and I get D minus 1/2 A T squared divided by T equals V naught. When I plug in my numbers, I should get negative 32 meters minus 1/2. The acceleration is negative 9.8 meters per second squared. Time is 3.8 seconds. That gets squared. All divided by 3.8 seconds. And that's going to equal V naught. I'm out of room to write here on the bottom, so I'm going to write the answer up here in the top area. When I plug in all these numbers into my calculator, I should get an initial velocity of 10.2 meters per second upward, so positive, for my initial velocity. And that's how you do this problem, where something goes up and lands at a lower spot than where it was thrown.